So I'm doing question 5 from the 2011 free response. And question 5 says, at the beginning of 2011, a landfill contained 1,400 tons of solid waste. And right there already we know that 1,400 tons of solid waste, it's giving us some values. It's probably going to lead to a point. The increasing function W models the total amount of solid waste stored at the landfill. Planners estimate that W will satisfy the differential equation dW dt equals 1/25 W minus 300, so we have the derivative of W for the next 20 years. W is measured in tons and T is measured in years from the start of 2010. So with that little bit of information that T is measured from 2010, we know that at T equals 0, W equals 1,400. So that's a point, and that's the starting point that we got. So for question A, it says, use the line tangent to the graph at W at T equals 0 to approximate the amount of solid waste that the landfill contains at the end of the first 3 months of 2010, time T equals 1/4. So right then, when I first read A, I just ignored the whole approximation part of it, because the first step in part A is just finding the tangent. And so when you're finding any tangent line, first you need to find a slope, and second you need to have a point. So first, because I had W prime, I decided to find the slope first. So I need to find the slope of W at T equals 0. So I just plug in 0 to W prime, and I get 44. 44. That's my answer. So that's my slope. And because of the point I was given in the question, I know that the y-intercept is 1,400. So I can just plug that right into my tangent. And then I attack the second part, which is the approximation part. So it says to approximate the amount of solid waste that the landfill contains at the end of the first 3 months of 2010, time T equals 1/4. So that's basically a fancy way of saying use the equation of the tangent line to approximate what T equals 1/4, which just means plug in 1/4 into your tangent line. So that's what I did, and got 1,411 tons. Don't forget the tons. Okay, in part B, it's find the second derivative in terms of W, and use the second derivative to determine whether your answer in part A is an underestimate or an overestimate of the amount of solid waste that the landfill contains at time T equals 1/4. So again, just in part A, you want to just stick with the first part. What they first ask you is find the second derivative. And so the second derivative is you just look at the derivative that they give you and take the derivative of that. And so you get 1/25 times the derivative of W minus 300, which is just W prime minus 0, because the derivative of 300 is 0. And so you get 1/25 times the derivative. And since we already know the derivative, since we already know dW dt, we just plug that in, and we get 1/625 W minus 300 as the second derivative. Now we attack the second part. So we need to use the second derivative to determine whether part A is an underestimate or an overestimate for the amount of solid waste that the landfill contains. So what I was first struck with reading B is what Mr. Shan always says, is that free response questions, they lead you somewhere. So clearly finding the second derivative has something to do with the underestimate or overestimate. And so what does the second derivative show? It shows concavity. So messed up a little here, sorry. because the second derivative is positive at T equals 0, the answer in A is an underestimate. And as you can see, I showed this with a graph. It's because W is always concave up, the tangent line will be underneath the function and not over it. So you can see this is something that's concave down. And this would be in the tangent line, say it's right here. That wasn't very good, sorry. In the tangent line, that's always above the points. It always has a higher value. So if the second derivative is 0 at t equals 0, the answer would be an overestimate. But since it is positive, we know it's concave up, which means A is an underestimate. So next is C.
Were you there?
Basically,
Were you there?
So C says find the particular solution W equals Wt to the differential equation dW dt 125 W minus 300 with the initial condition W0 equals 1,400. So in C, again, this fancy language for a relatively simple idea, which is just saying they want you to find W of t. And for that, we need, that's classic separation of variables, and that's just, very just algebraic, and yeah. So first you separate the variables. So you get W minus 300 equals 125 dt. And what might trip some people up is they don't see, where's the t here? How can I do that? And you're taking the antiderivative, not the derivative. So if you have a constant, if you take the antiderivative, that's the constant times the variable. So don't let that affect you or freak you out in any way. So you separate the variables, take the antiderivative, don't forget your c. So you find c, plug that back in, the arrow. So plug that back in, the arrow is equal to this point. So I'm just plugging in the c value that I found here. And then all you do is simplify. So whenever I see ln to the whatever, ln of something, I know that I'm probably going to have to do e and then ln w minus 300, because that cancels out the ln and that just cancels out the log. So then simplifying, you get w equals 1,100 e to the 1/25th t plus 300. And in this question, it's ln, the absolute value of w minus 300. And you can cancel out the absolute value because w is always increasing, so there's no need for that absolute value. And on the AP test, I don't know, maybe it's smart to just write, don't need absolute value because w was always positive, always increasing. I don't know, might help. I don't know how they grade, but yeah. So that is question 5. Not as difficult as it seems.